RJ45 and RJ11 are distinct connector types serving different functions. RJ45 connectors are used for Ethernet cables, facilitating network connections between computers and other devices. RJ11 connectors are designed for telephone cables, connecting phones and related equipment to a telephone network. The problem is the electrician incorrectly wired RJ45 jacks as RJ11 jacks. This misconfiguration prevents the jacks from supporting Ethernet connections. The primary consequence of this wiring error is the inability of connected devices to access the network. This can disrupt the functionality of computers, printers, and other devices that rely on a network connection. The solution involves replacing the RJ11 jacks with the correct RJ45 jacks. This task is relatively straightforward and should be performed by a qualified electrician. To prevent such wiring errors, always use the appropriate connectors for the intended application. RJ45 connectors are for Ethernet cables, while RJ11 connectors are for telephone cables. Always engage a qualified electrician for any wiring work. Understanding the specific differences between RJ45 and RJ11 connectors is crucial for proper network and telephone installations. RJ45 connectors typically have 8 pins, while RJ11 connectors usually have 6 or fewer. This difference in pin count reflects their different functionalities. Ethernet cables using RJ45 connectors are designed to transmit data at higher speeds compared to telephone cables using RJ11 connectors. The wiring standards for RJ45 and RJ11 are also different, further emphasizing their distinct purposes. When installing network or telephone systems, it is essential to verify the connector type and wiring configuration. Using the wrong connector type can lead to connectivity issues and system malfunctions. Consulting the 2014 National Electrical Code, or NEC, provides guidelines on proper wiring practices and connector usage, but that is outside the scope of this discussion. Firstly, ensure that the correct tools are used for terminating RJ45 and RJ11 connectors. Secondly, follow the appropriate wiring diagrams to ensure proper pin assignments. Thirdly, test the connections after installation to verify connectivity and performance. Ignoring these steps can result in unreliable network or telephone systems. The color coding of wires within Ethernet and telephone cables also differs, reflecting their respective wiring standards. Understanding these color codes is essential for accurate termination of connectors. Ethernet cables typically use the T568 or T568B wiring schemes, while telephone cables follow different wiring conventions. Incorrect wiring can lead to signal degradation, connectivity problems, and even equipment damage. It is important to note that while RJ45 connectors can physically fit into RJ11 jacks, this is not a proper configuration and can lead to problems. The electrical characteristics of Ethernet and telephone signals are different, and using the wrong connector can disrupt signal transmission. Always use the correct connector type for the intended application to ensure reliable performance. When troubleshooting network or telephone connectivity issues, always check the connectors and wiring. Damaged connectors or improperly wired connections can be a common cause of problems. Use a cable tester to verify the continuity and proper wiring of Ethernet and telephone cables. Replacing damaged or improperly wired connectors can often resolve connectivity issues. If you are unsure about the proper wiring procedures, consult a qualified electrician or network technician. They can provide expert assistance and ensure that the wiring is done correctly. Proper wiring practices are essential for maintaining reliable network and telephone systems. By understanding the differences between RJ45 and RJ11 connectors and following the appropriate wiring procedures, you can prevent connectivity issues and ensure optimal performance. Furthermore, ensure that the cable being used with the RJ45 or RJ11 connector is also rated for the specific application. For example, using unshielded twisted pair or up cable for Ethernet connections may be suitable for some applications, but shielded twisted pair or STP cable may be necessary in environments with high electromagnetic interference. Similarly, telephone cables have different ratings depending on the intended use. Using the wrong type of cable can degrade signal quality and reduce network or telephone performance. Always consult the cable manufacturer's specifications to ensure that the cable is appropriate for the intended application. When running cables through walls or ceilings, be sure to follow proper cable management practices. Avoid bending cables sharply, as this can damage the conductors and degrade signal quality. Use cable ties or Velcro straps to bundle cables together and keep them organized. Label cables clearly to identify their purpose and destination. Proper cable management not only improves the appearance of the installation, but also makes it easier to troubleshoot and maintain the system. Regular inspection of connectors and cables can help identify potential problems before they cause connectivity issues. Look for signs of damage, such as cracked connectors, frayed cables, or loose connections. Replace any damaged connectors or cables immediately to prevent further problems. Cleaning connectors periodically can also help maintain good signal quality. Use a contact cleaner specifically designed for electronic connectors to remove any dirt, dust, or corrosion. In addition to using the correct connectors and cables, it is also important to use the correct tools for terminating the connections. A crimping tool is used to securely attach the connector to the cable. Using the wrong crimping tool or improper crimping technique can result in a weak or unreliable connection. Always use a crimping tool that is specifically designed for the type of connector being used. Follow the manufacturer's instructions carefully to ensure a proper crimp. A cable stripper is used to remove the outer jacket of the cable without damaging the inner conductors. Using the wrong cable stripper or improper stripping technique can damage the conductors and degrade signal quality. Always use a cable stripper that is designed for the type of cable being used. Adjust the stripping depth carefully to avoid damaging the conductors. A punch-down tool is used to terminate the individual wires of the cable into the connector. This is typically used for terminating Ethernet cables into patch panels or wall jacks. Using the wrong punch-down tool or improper punching technique can result in a weak or unreliable connection. Always use a punch-down tool that is designed for the type of connector being used. Follow the manufacturer's instructions carefully to ensure a proper termination. When working with electrical wiring, always follow proper safety precautions. Turn off the power to the circuit before working on any wiring. Use insulated tools to prevent electric shock. Wear safety glasses to protect your eyes from flying debris. If you are not comfortable working with electrical wiring, consult a qualified electrician. In summary, understanding the differences between RJ45 and RJ11 connectors, using the correct cables and tools, following proper wiring practices, and taking appropriate safety precautions are essential for ensuring reliable network and telephone systems. By paying attention to these details, you can prevent connectivity issues and maintain optimal performance. When dealing with network installations, it is also important to consider the network topology and the devices that will be connected to the network. The network topology refers to the physical or logical arrangement of the network. Common network topologies include star, bus, ring, and mesh. The choice of network topology depends on the specific requirements of the network, such as the number of devices, the distance between devices, and the desired level of redundancy. The devices that will be connected to the network also play a role in the network design. Different devices have different network requirements. For example, computers typically require a high bandwidth connection for data transfer, while printers may only require a low bandwidth connection. The network should be designed to accommodate the different network requirements of the devices that will be connected to it. In addition to the physical aspects of the network, it is also important to consider the logical aspects of the network. The logical aspects of the network include the network addressing scheme, the routing protocols, and the network security policies. The network addressing scheme is used to assign unique addresses to each device on the network. The routing protocols are used to determine the best path for data to travel between devices and the network. The network security policies are used to protect the network from unauthorized access and malicious attacks. Proper network design is essential for ensuring that the network is reliable, secure, and performs optimally. A well-designed network can improve productivity, reduce costs, and enhance the overall user experience. When troubleshooting network problems, it is important to have a systematic approach. Start by identifying the symptoms of the problem. Then, gather information about the network configuration and the devices that are affected. Next, analyze the information to determine the possible causes of the problem. Finally, test the possible causes to identify the root cause of the problem. Once the root cause of the problem has been identified, take steps to correct the problem. This may involve replacing a damaged cable, reconfiguring a network device, or updating a software driver. After the problem has been corrected, test the network to verify that the problem has been resolved. By following a systematic approach, you can quickly and efficiently troubleshoot network problems. In addition to the technical aspects of network and telephone wiring, it is also important to consider the aesthetic aspects of the installation. A well-organized and aesthetically pleasing installation can enhance the overall appearance of the home or office. Use cable management techniques to keep cables neat and organized. Hide cables behind walls or in cable trays to conceal them from view. Use color-coded cables to identify different types of connections. Label cables clearly to make it easy to identify them. A professional-looking installation can add value to the home or office. When hiring an electrician or network technician to perform wiring work, it is important to choose a qualified and experienced professional. Ask for references and check their credentials. Make sure they are licensed and insured. Get a written estimate before the work begins. A qualified professional can ensure that the wiring is done correctly and safely. Proper wiring practices are essential for maintaining a safe and reliable electrical system. By following the guidelines outlined in this discussion, you can prevent wiring errors and ensure that your network and telephone systems perform optimally. Furthermore, always consult the latest edition of the National Electrical Code, or NEC, for the most up-to-date wiring standards and safety requirements. The NEC provides comprehensive guidelines for electrical installations, including wiring methods, conductor sizing, overcurrent protection, and grounding. Adhering to the NEC guidelines ensures that electrical systems are installed safely and meet the minimum requirements for performance and reliability. In addition to the NEC, local building codes and regulations may also apply to electrical installations. It is important to check with the local authorities to determine the specific requirements for your area. Building codes and regulations are designed to protect the public health and safety. Compliance with these codes and regulations is essential for ensuring that electrical installations are safe and meet the required standards. When planning a new electrical installation or renovation, it is advisable to consult with a qualified electrical engineer. An electrical engineer can provide expert advice on the design and installation of electrical systems. They can also help ensure that the installation meets all applicable codes and regulations. Engaging an electrical engineer can help prevent costly mistakes and ensure that the electrical system is safe and reliable. Regular maintenance of electrical systems is also important for preventing problems and ensuring safety. Inspect electrical wiring and equipment regularly for signs of damage or wear. Replace any damaged or worn components immediately. Test ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, regularly to ensure that they are functioning properly. Keep electrical panels and equipment clean and free of obstructions. Regular maintenance can help prevent electrical fires and other hazards. When working with electricity, always exercise caution and follow proper safety procedures. Never work on live electrical circuits. Turn off the power to the circuit before working on any wiring. Use insulated tools and equipment. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you are not comfortable working with electricity, consult a qualified electrician. Electricity can be dangerous if not handled properly. By following proper safety procedures, you can prevent electrical shocks, burns, and other injuries. In addition to the technical aspects of electrical wiring, it is also important to consider the environmental impact of electrical installations. Choose energy-efficient appliances and lighting fixtures to reduce energy consumption. Use renewable energy sources, such as solar power, to generate electricity. Recycle electrical equipment and components properly. Reduce the use of hazardous materials in electrical installations. By making environmentally conscious choices, you can help reduce the environmental impact of electrical systems. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific advice on electrical installations. Electrical wiring can be complex and dangerous. It is important to have the knowledge and skills necessary to perform electrical work safely and correctly. If you are not qualified to perform electrical work, hire a professional. Your safety and the safety of others depend on it. Remember that electrical codes and standards are constantly evolving. Stay up to date on the latest changes to ensure that your electrical installations meet the current requirements. Participate in continuing education courses and seminars to enhance your knowledge and skills. By staying informed about the latest developments in the electrical industry, you can provide your clients with the best possible service. Finally, always remember that safety is the top priority when working with electricity. Take the time to plan your work carefully and follow proper safety procedures. Never take shortcuts or compromise on safety. Your life and the lives of others may depend on it.